Welcome to episode 20 of the Everyday Expertise podcast. I'm your host, Roland Martin, and I hope that today's conversation will expand your knowledge. Today I welcome Jamie Shantz to the show. Jamie works for a company that provides design, consulting, and project management services to the feed and grain processing industries. Jamie works specifically on the automation side of this company and spends most of his time designing computer programs that run the automation systems that these feed mills use. So basically, Jamie's a computer programmer. I really enjoyed talking about programming with him. This term at school, I was required to take a computational physics course, which is a course that teaches us how to use computer programs in order to figure out physics problems. And the first few weeks of the course was just an introduction to basic programming. I wasn't too sure about the course before starting it. Didn't know if I would enjoy it, but I found that I really do. I enjoy how logical it is. I like that you can always predict exactly how the computer program is going to work and what's going to happen next. And because of that, I have gained a little bit of knowledge and was able to better understand the things that Jamie was talking about in this conversation. Jamie told me that people often have trouble connecting with him when he gets too deep into describing his work and the things that he does. And I think the reason for that is because learning computer programming is a bit like learning a new language. There's lots of terminology and concepts that are not familiar to most people and not terms that we use just in our regular life. And so because of that, if you don't have any experience with it, there might be a few concepts and a few terms that we talk about that you're not familiar with. But hopefully it'll be a chance for you to learn a lot about some of the ways that computer programs can work and the ways that they can be implemented and to make systems more useful. In this conversation, Jamie talks about how he got into his current career. He talks about some of the things that the systems that they design for feed mills work and what they're supposed to do. And then we spend time talking about programming, how he approaches his creating programs, and talks a bit too about the computers that these programs run on and some of the fascinating things that they can do. So I really hope that you'll enjoy this conversation and learn from his expertise. Welcome, Jamie, to the Everyday Expertise podcast. It's really good to have you here.
It's good to be on.
So, tell me, what does your life look currently, or what keeps you look currently, or what keeps you busy these days?
Outside of work, not a whole lot with COVID going on. It's
right.
Kind of, evenings are pretty free for the most part, and weekends. So, it's pretty much just work and.
Yeah. So tell me a little bit. What does work look like for you? What are some of the things that you do?
So right now we're working from home,
Mm-hmm.
at least on the automation side of the company. So I usually start my day at 7, and that means walking down the hall to a different room in the house.
Mm-hmm.
And my day is spent almost entirely just on the computer.
Okay.
And it's hard to say what a typical day looks like. They vary quite a bit. Sometimes, depending if I'm like in the middle of a project or something, then most of the day is spent programming,
Mm-hmm.
writing code. But sometimes a lot of the day is spent troubleshooting,
Okay.
or working through code that's already been written and trying to debug or whatever, or
Mm-hmm.
testing.
Okay.
Sometimes that type of thing, and then sometimes too we're out on site, so then I'll get out and go to whenever there's a startup of something new or anything like that, implementing new code, then I'll be out on site.
Okay.
So,
Is that include like troubleshooting and things on the?
yeah. So some of that we can do I can do from home. Like we have remote connection to a lot of our sites. So if it's a call or whatever, if you can do it from home, you will. Mm-hmm. But if it's any physical issue or whatever, then obviously you need to be on site. So.
Yeah. Are these like big projects, like ones that you work on for months at a time? Or?
Yeah. So, like a year for a big, like a mill or whatever it'll be.
Right.
Or at least somebody will be. And sometimes some of it is you work on it for a while, and then it might get shelved for a month while you're busy doing like a smaller project or whatever, and then you come back to it.
Yeah.
That type of thing.
So within a day, will you be jumping between projects? Or?
Yep.
Okay.
So some days it's between a lot of projects. And those days, sometimes it feels like you get less done.
Okay.
You're jumping here, or your day might be interrupted by a call from somebody, and you need to do some troubleshooting or whatever, finding an issue.
So something you weren't planning necessarily.
Yeah. So usually that doesn't matter. Like you'll be working on something that is months away yet.
Okay.
And so then the immediate takes priority.
Right.
Always, right?
So are you kind of given a list of things that projects for the next while, and you have to decide, or are you on a daily basis as a team deciding who works on what?
So we have a meeting every day with the automation team. Right now because we're working from home, we used to do it weekly.
Okay.
But it's kind of, you're given a project to work on, and often then you'll be on that for weeks or whatever.
Okay.
So sometimes you might be given a few different projects, and they'll take a day or two each or whatever, something like that. Or sometimes you'll be given a small project, and then it'll be kind of a big project that's still months away is kind of your backup thing. That's what you work on when you don't have something else to work
so there's
on,
always something to do and something to work on. Just on the work from home thing, are you still is there set hours that you're required to be on the clock, as it were, or are you kind of free to put your hours in whenever, or just get your projects done?
I don't know. That'd be a question for somebody in management, I guess. I keep the same hours. We all pretty much do.
Okay.
Keep the same hours that we do. We don't actually all work exactly the same hours, though.
Okay.
It's fairly flexible, and it was when you go into work too. I work 7 to 5:30, sometimes 5. If you need off earlier, usually it doesn't really matter if you have to. Some people start a bit later, and then whatever. So it's not set. It will be. So right now, if somebody gets a call at work and they forward it to my extension at work, it will come to my cell phone. So it's kind of expected, right?
There are some things that kind of keep you to a certain schedule. I don't know if it's this way anymore as much, but when the work from home thing got pretty big back in March there because of COVID hitting, I heard some discussions about if there should be schedules, or if people should be free to work when works best for them and that kind of thing. So sorry to keep hitting this, but I've found it fascinating that you've been working from home this entire time. Do you think that your team will go back to working in one location again, or do you think this is going to be an ongoing innovation that you work from home?
I'm pretty sure we'll be going back to the office at some point. It works pretty well to work from home. All of us right now in the team have been there for more than 3 years. Trying to train somebody new would be almost impossible from home. Right. So if it's something like that, then it becomes pretty tricky. So there's probably advantages and disadvantages, but I guess you have to make that call at some point if it is an option again. Go back. We'll get more into how you got into it, and then about the specific work that you do. But before that, maybe just a little bit more about you. Do you have any hobbies or interests outside of work that you'd like to share? So beyond work, I know some people that are programmers, and their hobbies are programming, and that is not me. I hardly do any of that outside of work. I like sports. I like to run. This summer I got into disc golfing.
Oh, nice.
I like reading. I play piano some, not as much as I'd like to often, but so. And I like other little projects around the house. Working whatever with my hands, building things or whatever. In Waterloo, I don't have a lot of chance to do that type of thing, but
I was going to ask if you do things on your house, like home improvements and that kind of thing.
We did a renovation, a little one, put in a new fireplace and stuff this spring. And so that was fun. I like to do that, but I'm also, my father-in-law helped a lot with that. So it's not something that just am willing to do all on my own,
Got
but
you.
I enjoy
Got some good
it.
help
Yep.
help for it too. Yeah. Oh, that's great. And it's nice to love your work so much that you enjoy doing it outside of your scheduled time of work. But that's great if you have other hobbies and interests and are able to get away from work for a while too and do other things. So that's great. So yeah, I'd like to hear about how you ended up in the work that you're doing, how you got into programming. You said, I forget if it was on the recording or not, that I think it was before we were recording, you said that you didn't go to school for it
Right.
specifically. So I'm kind of curious hearing how that came to be and that kind of, how your career path has gone. So my first question, I guess, is what did you go to school for and kind of how has that developed into where you are now?
Yeah, so right out of high school in grade 12, I co-opted at Horse Systems to be an electrician. So
Okay.
I was in the electrical department there, and I got into the trade, and that's what I went to college for. So that's trade school is, it's 3 semesters split apart, like 3 different years, and it's just the first one's 8 weeks, and the second 2 are 10 weeks.
Okay, so it's not a lot of class time.
No.
Yeah.
And then to become licensed, you need, to pass that, and you need 9,000 hours of working experience. So school counts as part of that, but it's more or less 4 to 5 years of work experience.
A lot of on-the-job
Yep.
training to learn that profession.
Yep.
Yeah.
And then there's an exam at the end, the C of Q.
Is that a written exam or is that a
Yeah.
practical?
No, it's written.
Okay.
And on it there'll be practical questions.
Okay.
Things, but a lot of it's code related to the
Like
code
building
book and
code
stuff.
or
Well, there's like a
electrical
whole
code or-
electrical code.
Yeah,
Yeah.
okay.
A whole big book just on that. So
Okay.
yeah. So some of school is doing some of that. You do hands-on stuff in school. So there's labs
Okay.
where you actually do wiring.
Mhm.
And and then there's theory too. So what electricity is and the
Right,
theory of it,
yeah.
that type of thing. And you learn code. And then in the third term, you get a little bit into programming. So because quite a few electricians or quite a few jobs require at least a little bit of knowledge in programming. So that would have been really my first introduction to programming.
Okay.
At all. So
Is it related to, so I see at university, there's like courses or a degree in electrical engineering.
So yeah, that's different.
Okay. Is it
like,
totally different or is there some a little bit related?
I don't actually know for sure what they all do, but you wouldn't need to be an electrician, I
Right.
don't think, to be an electrical engineer. And that would be a lot more in planning. So like those high rises and stuff, you wouldn't just have an electrician just go in and wire it.
Yeah.
That would all the drawings would get done and load calculations. And so they would probably be even more intensive in the code side of things.
Okay.
I think for
Right.
especially like sizing things and stuff. So
Yeah. Okay. So you got your license? Is
Yep,
that what
yep.
what you become when you
Yep.
what you get when you become an electrician?
yep.
And then were you working as an electrician after that? Or?
Yep. So I did my whole apprenticeship at Horse Systems, and then I became licensed. And that doesn't change a whole lot what you do. Often that kind of a licensed person is often kind of a foreman, or at least a lot of smaller companies. So I would have just kind of gotten to the point of doing some of my own jobs at Horse Systems, and we did a lot of travel there. So I was overnight for like often it would be 3 nights a week or whatever.
Oh, really? Okay.
Certain jobs that you had, it would be like we had some jobs other side of Toronto. So it would fairly often there would be maybe 6 weeks, 8 weeks out of the year where most of the week I'd be gone.
I see.
for
Yeah.
the week. So I had just gotten married, and that was actually the reason that I was looking for a different job.
Okay.
It was more that than anything else.
So you enjoyed the
Yep.
electrician work?
Yeah, no, it was fun. I liked it.
That's great. Yeah. So did you have something in mind as you were looking for a different job, different career?
So I liked what I did as an electrician, but I didn't like what I did. I figured was probably about what I would like best. So being an electrician is pretty broad. You can wire residential houses or you can do commercial, or so we were kind of in the agricultural.
Okay.
And a lot of it was working with rigid conduit, so it'd be like bending steel, so it kind of taking pride in how things look.
Okay.
So I still like look at that type of thing when I'm walking through big buildings or whatever. But so I liked what I did, but I didn't really want to look for a different electrician job.
Okay.
That wasn't really. I maybe would have considered some things, but I was more interested in programming.
Yeah. So had you had any experience with programming before?
No, not really.
Wow.
So
Okay,
yeah. Starting at CAMR, the first weeks were intense.
Mm-hmm.
Yeah. I learned everything that we will probably talk about later on in this podcast. I didn't know until I started working.
Okay.
So, yeah.
So you took the job, you were hired with the expectation that you would learn what you needed to on the job.
Yep.
And
so it's not that what I had known was useless, especially just in where I was working. And I'd actually done some electrical work at one of the projects that CAMR was doing.
Oh,
so
okay.
At Wallenstein Mill
Yep.
4, when they were building that, I was subbed out and doing some electrical work there and stuff. And it was similar to what we did. So just having an understanding of equipment and how things run and that type of thing goes a long way in writing code. When you need to control it, you have to know how it's supposed to work.
So you weren't totally starting from scratch in the industry that CAMR's working in, is that?
No, not totally, but as far as like feed mills, I knew very little.
Okay.
So yeah.
So you learned a lot about that side of things as you went also. Yeah. So yeah, what's kind of been your how did you learn? How have you developed since you took that job? How long have you been there now and been doing this?
It was 3 years in June, so a little over 3 years.
Okay.
Yeah.
So yeah, what's been the process of learning it, or do you just get thrown in and and start? Or
so the first month I didn't accomplish much at work. There was definitely some training. We did some of it. A lot of it was just learning by like very supervised work.
Okay.
So I would do something and I would constantly be asking questions, and some of it was just Google searches or whatever, going to certain websites that had a lot about it. We did pretty soon after I started. So the PLC, most of our hardware comes from Beckhoff, and when we work with them, and they provide training and stuff too. So pretty soon after I started, we had somebody from Beckhoff come in and do a week of training, where it's just writing code and learning things about the program that they have for writing.
And this
code.
was just with you, or were there others?
No,
that
this
were
was
learning too?
actually all of us. Did it there in the automation side. So some of that was definitely beyond what I knew at that point too. I mean, I heard it and it went over my head at that point. So.
Yeah.
And then there's also certain aspects. So we do a bunch with databases.
Okay.
So I've done training with online courses. Some of it I was down in Toronto for a week doing just a week of training on databases. So there's certain things like that, and it's kind of ongoing. So at the beginning I had some of that, but it's also I've done refresher courses and more in-depth ones since then, and I'm sure I will in the future too.
Yeah. Are there like online tutorials and things that you can do, or where do you do that?
Yeah, so those courses it's through Global Knowledge, so they actually it's actually a course.
Yep.
But there is certain W3 Schools is a website that if you're ever interested in just about any popular programming language, they have like very in-depth tutorials where you can try it. They have like a little description about how to do something or what it does, and then like an editor there where you can try the code and stuff. So some of that, not so much in the PLC code. That would be a lot more languages like web development languages and that type of thing.
On this website
Right.
that you're
Yep.
talking about, is it something you have to pay for? Or?
No, that's all free.
Oh, really? Okay.
Yep, that site is.
Yeah. I think I was telling you about this maybe on email, but I have been taking a computational physics course this semester where the first few weeks we were introduced to computer programming with Python.
Yep.
And we just learned some of the basics so that we can write some code that you might use for a physics calculation or something like that. So I have a very minuscule introduction to that was the first computer programming that I've done. But
well, you might know more about Python than I do then.
Okay.
I don't ever write. I've definitely heard of it and seen a little bit, but I've never really written in Python.
Yeah, there's a lot of different programming languages, right?
Yeah, a lot. Python is pretty popular in that type of thing, what you were talking about, I think. So.
Yeah. I saw that there was someone that rated, or some site or company that rated which languages are used most often in programming. Yep. And Python is number 2, or they just passed Java, I think.
Yeah, that could be.
And then is there C or
C++?
So
there's a bunch based on C. There's C and there's C++ and C#.
Okay.
And
Okay. One of those was number 1. So
yeah.
Anyway, that's just to give you a little bit about what I'm coming to this conversation with.
Yep.
So yeah, you can maybe talk about what you've been learning as we get into talking about some of the projects and some of the things that you do in your work. And yeah, maybe this will just give us a little bit more about what the company that you work for does. And if you give us a bit of a description of some of the projects that you guys do, just to give us a little bit of context for what you're talking about here.
Yep. So KMR, there's only around 10 of us right now that work there.
So a very small company.
Yeah, it is. Yeah. It's quite small. And it's kind of split into 2 divisions. So there's the engineering side and the automation side. So I'm on the automation side, but it would be somebody comes to KMR with mostly what we do is building new feed mills. So popular one in the area, Wallenstein. When Mill 4 was built, we would get it right from the beginning. So the design side is involved in a project long before we are, with like different things that you need to actually build a mill. So sometimes there needs to be different studies done or whatever, and permits, like and all of that type
even
of
on the
thing.
land and that it's going to be built on and that kind of thing. Yeah.
So fill brought in and whatever, that type of thing, just to make sure. And then they do the design. So some of
this is building and everything, like building and equipment, or just the equipment?
Mostly. So we would be they would do all the drawings for the equipment, and a lot of the drawings for like layout, all of that, like where equipment belongs and stuff. But as far as actual structure, those drawings would be obviously part of ours. Like you have to know where things are, but that wouldn't be what we do. We wouldn't do the structural drawings. So, so they're involved right from the beginning, and they might be a year in or whatever before we really on the automation side get involved very much. So at that point, by the time we get involved, there's a full equipment list, like a list of every piece of equipment that there's going to be, and motors and sizing of that is all done and stuff. And a flow plan, so something kind of where that takes product comes here and where it flows through the mill, like to every place it can go to, and every piece of equipment that it goes through on the way is documented. So that's kind of our starting point. Yeah.
So just to jump in there, how much do you personally have to know about how a feed mill works?
So the better you know it, the better you can program it.
Okay.
So it's I don't know near as much as what some of the people on the design side would, and you don't need to. Right. But you'll think of things. That will make it better, your program better, if you understand it. For sure.
So just to back up to that a little bit, are are these feed mills, these programs that you're writing, is it mixing? What are they doing at these?
Sure. So an analogy, this is an analogy I used with my wife.
Okay.
is it's like a recipe. So you have, except all your ingredients are stored in bins.
Okay.
And then you weigh them out into a scale.
Yep.
And that
That
comes
also
from,
this is
that
all
all comes-
preset.
Yep, that all comes from a formula. So they would have nutritionists or whatever that decide what formula is best, like a recipe.
Yep.
And then they send that to our system. So they interface to our system.
Okay.
So we get that, and it says all the ingredients and what weights to make, and then the full. Typically, the recipe is set for like 1,000 kilograms, like a
Right.
1 ton or whatever. But then they say an amount, how many tons to make.
Yep.
And then based on that, it would be an operator would basically select that and hit start, and we would automatically weigh things out into the different scales. So we have to know what products are in what bin and which scales they go into. Often there's multiple scales.
Okay.
And you obviously can only weigh one thing at a time because you need to know the weight of
Yep.
that product.
Okay.
And then from there, from the scale, it does go into a mixer, and that just mixes it. And often at that point, liquids are added. So again, it's like a recipe or whatever.
So there's
So
dry mixes, and then
so that all comes from bins, and then there's liquids that get metered in, like they're pumped in.
Okay.
And so we meter that, keep track, and again, it's to make sure you get the right amount. With the dry product, there's often medicines that get added.
Okay.
So that's much smaller quantities. So then we have different scales for that.
Is that a dry ingredient as well? Okay.
Yeah. And so that's those scales are our highest resolution scale, would weigh to within about 1 gram.
Okay. So it's not super precise with.
Right. But that's 1 gram over.
And you're making like your recipes by the 1,000 kilograms.
Right.
Yeah.
Exactly.
Okay. That is pretty precise then.
Yeah. So, a typical batch size might be, I think it goes 4 ton, something like that.
Okay.
It might go for one batch, but then you might have an order that's 20 ton. Or
Yeah. Okay.
So maybe multiple batches then. So then from there it goes to what we call a mash bin. So that's after it's all mixed out.
That's after the liquids in it with it as well.
Yep. So then it goes into a different bin, and that bin is typically above the pellet mill.
Okay.
And so then if you've seen feed, you can probably kind of picture what pellets are like.
Yep.
I mean, some dog food is kind of in that form or whatever too, although often
so is it kind
different.
of a hard?
Yeah.
By the time it gets to its final product?
Yeah. So the pellet mill is really, it comes in as mash, and sometimes liquids are added there again.
Okay.
And then it's basically a roller, and it pushes it through a die to make it into pellets. So then the pellets from there, it goes often through a crumbler. So your pellet might be fairly long or whatever, and then a crumbler would break that pellet down. So it's a smaller size.
Piece,
so depending the feed. Yeah. So from there, and then sometimes liquids are added again after that. And then it goes into a load-out bin where it would get loaded on a truck. Okay. So that's kind of the full process of a feed mill.
And you're helping to automate all of that
whole thing.
Process?
Yep.
Okay.
Yeah,
Wow.
so there's a few different spots where product sits. So you kind of can break it into different processes or whatever. So receiving would be somebody comes in with something from the field, corn or whatever, right? Wheat. And then it goes into a bin, and that becomes what you pull from then for your ingredients.
Okay.
So, and obviously there's other ones, like the medicine ones would be a much smaller bin.
Okay.
Where they just pour in a bag or whatever.
But that's all part of the automated process as well. From the ingredients coming into the mill till they go out.
Yep.
And do you even help automate the loading and unloading process?
Yeah. So that's a truck driver when he comes in would be looking at our screens.
Okay.
Out there.
And do you help with programming inventory controls and that kind of thing too?
Yep.
Okay.
Yeah. So we keep track of everything that comes in and goes out, and actually keeping track of what goes in, like actual amounts. So you have your target amounts in a batch, but we keep track of what actually goes in too, right? So there's tolerances that you're allowed to be off by.
Okay.
And so all of that actually becomes by a federal standard. You have to keep that data for 10 years.
Oh, okay.
Yeah, so it becomes.
So is that where the databases come in?
Yep.
Like you're feeding
Yep.
into databases all the time?
Yep.
And yeah. So when you're talking about, just to clarify something here, you've been saying does this mean that you're thinking about this as you write your programs and put this all together? Or are you as a company giving ongoing support and helping run these programs after they've been implemented and the mill's good to go?
No, ideally it's we write the program
Okay.
and that's it. We don't hear from them again, obviously.
So you were saying we as in that you're thinking about all these things as you
Yep.
come up with the plans
Correct.
and
Yep.
put it all together. Yeah.
Yeah. No, it's the person that actually runs it. It's just an operator that works at the mill.
Yeah.
Yep.
Yeah. Very good. Yeah. So that helps give me a little bit of context for
Yep.
what you're talking about here, the industry that you're working on within. And I mean, automation could go so far beyond what you're gonna talk about
Yep.
here, because there's so many different industries and manufacturing and things like that automate their systems and maybe would have some of the same concepts, but I'm sure that there's lots of differences too. So, yeah, I guess with my next question here, and anytime when I go on to a question, feel free to go back
Yep.
and fill in anything that we missed or that would help make more sense. But what are some of the elements that allow an automation system to operate? So you've talked about the physical, what actually happens, that the product needs to be moved and made into the pellets and all that. But so there's computers,
Yep.
what are all of the different components that are needed to make these systems work?
Yeah, so going back to when I worked as an electrician, then we would be wiring the motors, and you wire
Right.
those back to a motor control cabinet,
Okay.
which has, it's like a contactor, which it just pulls it in to turn the motor on and off.
Okay.
And so then that there then is controlled often by a lower voltage. So you might have a 600 volt motor, and it's controlled by control wiring.
Okay.
That would be wired then to our output cards. So
Okay.
all of that, what I just talked about, we don't do at
Okay.
all. That we're from the control side beyond. So
Are you controlling that control thing that you were just talking
Yes.
about? Okay.
So we would have a computer. An operator would sit at a bank of monitors, often multiple monitors. It's
Okay.
usually, well, for the batching side, there's often 6 monitors that he's
Mm-hmm.
sitting in front of. And that would be our computer. Like, we provide
Okay.
that computer. What he's looking at is a program that is written by us
Nice,
in the
yeah.
automation side. And when he clicks start on a motor or whatever, then that communicates to a different computer, which is the PLC. So that controls
Does that stand for something, or?
programmable logics controller, I think.
Okay.
But
Yeah.
yeah.
So I hear that term thrown around,
Yeah.
some, but I didn't know what it actually is. Okay.
Yeah, so that's the PLC, and the other one is HMI. That's the user interface. That just stands for human machine interface, I think.
Okay.
I think that's what it is.
And that's what you guys
So
set
we would
up?
do both. We would
Okay.
we would program the PLC and we'd program the HMI.
Okay.
So one is what controls your inputs and outputs. So telling a motor to start
Yep.
is an output. Having feedback that a limit switch is hit
Okay.
or whatever is an input, that type of thing.
Yep.
So the I/O, like at that level, is what the electricians would wire into to go out to start a motor.
Okay.
So
And you said you did that?
yeah, that's what I would have done as an
Yeah.
electrician.
Okay.
So I kind of have that side of things a
Yeah.
little bit. Yeah.
Has that helped at all with
Yeah, it definitely understand things a little better coming from that.
Yeah, very good.
So, yeah, there's the kind of the I/O, which a big project might have, like our largest projects, I think, have over 1,500 I/O points.
Okay.
So outputs or inputs.
Yep.
And then the PLC is what controls that, and our code would reference a certain output to tell it to turn on.
Okay.
Whatever.
Yeah, very good. So that's the programming side of things. Are there, maybe this isn't your I don't know if you work with this at all, but are there like sensors then within the within all the equipment, or how does that?
So typically, the automation side, like the design side, would often pick out sensors.
Okay.
So that would be So a two-way valve, so that's something that you can go one path or another path. It's exactly what it sounds like. You have to know which way it's pointed to. So
Okay.
you would have a sensor for it pointing left and a sensor for it pointing right or whatever. Okay. And so that would get, those sensors would get wired back in. So we don't really do sensor selection, but we absolutely in the code need to know every sensor out there. And we have to have a drawing basically that says where, which input card it comes to and the exact point that it's wired to.
Okay.
So
yeah. So you're not doing any of that wiring though?
No.
No, you just basically writing the computer program that's going to control all of this?
Yep.
Okay.
Yep.
So do mistakes ever come in or something not work because something was wired incorrectly?
Yeah. So that's in startup, when you're starting up a big project, starting up a mill takes weeks. Like right. It's not just something if it's new. But so that once a wiring, those will mostly be figured out when you're starting up a project. Okay, if there's a wiring mistake, that doesn't just happen a year down the road, right?
Yeah.
Unless somebody's been messing things. Yeah. So, but there's sensor failures or something like that. So then it becomes, it's not, if you get a support call, you have to keep it in your mind. Is it an issue with the code that I've written where something got messed up, like in a state that it shouldn't be or isn't normal?
Okay.
Or is it actually a physical issue? Is there a sensor that is broken or something? And some of that we would just replace, like some sensors we have in stock.
Okay.
And depending what it is, an electrician would tell them to call an electrician or whatever.
But you also run into problems, like you said, that your code is the issue.
Yep. Yeah, that sometimes happens.
Yeah, and I'm sure we'll talk more about how you find those things and work with them. Yeah, anything else that you wanted to say about some of the things that are needed for an automation system to run or operate?
No, I maybe we'll come back to it at some point. But.
Yeah, and I want to know more about kind of what how you come up with your programs and things like that. I've in conversations before, I've enjoyed talking with you about physics a little bit, and I know that you're a little bit interested in it. So I'm wondering if that comes into your work at all, or if having a knowledge in physics benefits you at all.
Yeah. So, not actually in school. I didn't take physics, and that's something I really wish I would have. Yeah. But as far as what I do, it's not. You don't need an extensive knowledge of that sort of thing. Yeah. And the design side maybe more so, or whatever, like engineering things. And so there's certain things where you do have to know, depending when you get into motion of things.
Right.
Then, yeah, there's a certain extent. But some of that's done through physics. Some of it's done through trial and error a little bit.
Yeah. So you can figure out like timings of things just by playing with them a little bit.
Yep.
Yeah. So I guess it would be nice to have that all perfect before it gets implemented, but some of that you figure out as you go, kind of.
Yeah, and some of it's done in charts or whatever, like that manufacturers have made and things like that, where you don't need to do the math actually.
There's a lot of that stuff that's been put in place already.
Yep.
Yeah, very good. I was thinking a little bit about automation, and I don't know if you think about this at all, being involved in coming up with systems, and so I don't know I apologize if I'm asking you something outside of your realm here, but I'm fascinated by the idea of the advantages that come from business, a company being manufacturers being able to bring in automation and do that. So looking specifically at milling systems here, have you seen some of the advantages, some of the things that a mill can really benefit from in having an automated system?
Yeah, so definitely efficiency. There is, it can come down to there's almost no wasted time. You can have it if your operator is ready to start the next order. You can equipment can be running all the time.
Oh wow!
And it can be kept maximum efficiency.
Yeah.
That's definitely a big thing. Another thing is workforce. So back in the day, to get things to fill the scale with the ingredients, it would have been somebody basically running a slider and trying to hit the right target.
Okay.
So now,
stop it at the right time. Yeah.
Yeah. So now that's all done with automation. So it's a lot more precise.
Yeah.
Than
So
it used
less
to be.
wasted materials, better recipes. Like, is there more consistency in the products that are being put out?
Yep.
Yeah.
Yeah. And then to run, as far as to run the mill, so all the different processes that I said, you could do it. Obviously, this isn't what it is, but you could do it with 2 people.
Okay.
So it's automation certainly has a lot of benefits.
Yeah.
It becomes and the other thing then is everything gets recorded. So right, like even we record like every click of the mouse. Every time somebody clicks a button, we know that it got clicked or whatever. And so there's obviously traceability. Yeah.
To be able to, and that's important with the feed that they're doing. Like if a herd of animals would get sick or something, you can trace that and see exactly what went into it, or maybe where the problem occurred.
Yeah, you can. Yep.
Wow. Yeah, that is powerful. Do you see any disadvantages that come out of automation?
Not really.
Right.
There's certain things where sometimes if something goes wrong, then if it wasn't for the automation, you would just bypass it. So take the example of a limit. Maybe that is positioned to the right spot, but because we don't see that input, we don't allow anything to run.
Right.
Because we don't know it's there.
Yeah.
So that in that place or whatever, it just needs to get fixed. So there's certain maintenance that needs to happen. And the other thing is you become reliant on your code, right? So if the PLC were to crash or something like that, nothing would run.
Oh,
right?
I see.
There's not manual provision really to use your equipment, but all that is taken care of. We have backups. There's RAID drives on the PLC so that one can fail and it would switch over to the other one. So there's all kinds of different things that you put in place to
you have contingencies in place to keep some of that from happening.
So I don't know. I don't think it's much of a disadvantage.
Yeah. I mean, we get frustrated at technology sometimes because it's not working or if there's an issue, and we forget about how often it's made our lives easier for the last 2 weeks when it's been working perfectly, how much we benefited from it. So it's easy to forget about those things. Yeah, so want to get into what I think this is what you would spend most of your time with. You can correct me if I'm wrong about that, but looking specifically at computer programming. And so, just give us a description from your understanding of what is computer programming and how does it work?
Yeah, so I'll talk a little bit about the PLC program that we used first. Mm-hmm. That's written in structured text, which if you're not a PLC programmer, then you've probably never really heard about.
Right, I've never heard of that.
Yeah, but it's similar to other programming languages.
Okay.
So what it looks like when you're looking, a lot of people, if you've never seen programming, you look at code and it looks like gibberish. Mm-hmm. The easiest way to explain it or think about it is thinking about algebra. So there you know that if x plus 3 equals 10, you can figure out x is a variable.
Mm-hmm. So you use a lot of variables in your programming? Yeah.
So
well, that's similar to the little bit I've done then.
Yeah. Yep. Yeah, there's programming languages all have similarities, and that's one of them. Everything's written in variables. So when you look and it looks like gibberish, it's actually a variable name that's given. So if I want something to just take the very basic example of a motor starting, I might make a variable called start motor.
Okay.
And then then I might have my output linked to a motor start variable. So then there's keywords in programming. So words that mean something to the language, you can't use them as a variable.
Right. Yeah.
So that would be an if. I can say if my B start, that's my start variable, then I can set my output true.
Okay.
Essentially,
Yep.
to come true.
And that's how you can set up a series
Yep.
of events that take place? Okay.
Yeah. So yeah, everything can be, everything's a variable, basically, when you're programming. So
are there do you use the term loops at all?
yeah, so that's a very, well, so you almost have to start getting into data types a little bit when you talk about this. So a basic things are a Boolean, which is just true or false.
Right. Yep.
And then you have your integers, which is numbers. And then you have strings, which is text.
Okay. Yep.
And then you might have like a real or a it's called a real in structured text.
What is that?
So that's like a floating point number. That's the word I was looking for.
That's what I would have been used to call it.
So anything that decimals.
Yeah. A decimal number, basically.
Yeah. And so then where you get into loops is if you make an array of things.
Yep. So tell us what an array is.
Yeah. So think of an array as being kind of like, if you think about Excel, Excel can be used to explain a bunch of things. An array.
Well, Excel is basically program. I mean, you can write basic programs
with
it, right? Yeah.
So an array, but thinking about it just at a table level. So you have your Excel sheet. An array would be adding another row, or whatever. So you have, if your data type is a Boolean, and if I have B start, I could make it an array size of 3.
Okay.
And now B start, I have array position 1, array position 2, array position 3.
Is it kind of a way of compiling or putting together sets of data or different?
The reason to do it is so that you can use loops. So it becomes a lot easier. So when you have, if I just have B start out, then maybe I should use it. Switch to a different method of explaining here.
Yeah.
So let's use it for you're programming a game, and you have persons that are part of the game. So you might have player.
Yep.
So you might have player 1, player 2, player 3, and player 4. Now you could make variables that are exactly that, player 1.
Yep.
Or you could make one variable called player and make it an array size of 4.
Okay. Yep.
And now instead, so then before, if I want to write logic so that player 1's score becomes something from an input or whatever, then I would have had to write, if I wrote them all separately, I would have had to write player 1 score equals this, whatever. But in a loop, if you do it as an array, then you can loop through it. I can say for 0 to the size of the players.
And there it's for FOR, right?
Right.
Yeah.
Correct. Then for 0 or whatever to your player max, the size of players, player, and then I might assign the variable I. That's typically what it is in programming, to be the loop reference. So the first time through the loop, I is 0 or 1, or depending what you start your array at. And then it's 2 the next time through, and 3 the next time through. So now, instead of having to write the code 4 times for each different player, I write it once, put it in a loop, and it will happen 4 times in execution.
Yeah. So, and run through each thing in succession.
Yeah. So it would, when your code is doing it, it would start at the loop, at the beginning of the loop, and go through writing to all of player 1. So then it would be player, and instead of it's square brackets for an array usually.
Okay, well there's a lot of similarities in the language I use then. Yeah.
Once you know 1, the second becomes way easier to learn in programming languages. So then you would have, instead of a hard-coded 1 in the array position, you would put your variable I.
Oh, yeah.
Because that changes every loop. So the first time through the loop, it is player 1 because I equals 1.
Yep.
The second time through the loop, it's player 2 because I equals 2. So on.
So what's an example where you would program in a for loop with the programs you write? So
another reason to use loops is because it becomes way easier to add. So there's certain things, take a conveyor. There's certain things about a conveyor that happen to every conveyor.
Oh, yeah.
So if we make it the conveyor instead of, if we want to add a conveyor, sometimes there's different projects and they add a conveyor. then instead of having to write a whole bunch of new code, you just change your array size.
Oh,
your
and
array,
just add in that.
Make your array
basically
size
one
bigger.
time?
Yeah, so sometimes it can, certain pieces of equipment have become, so obviously for a conveyor, you might rely on other pieces of equipment to be running and stuff. So that has to be hard coded. But for certain pieces of equipment, like adding a fan or things like that, it's become to the point where we can make a database entry and change an array size. And then all the code's already in place.
Oh, wow.
Yeah.
So
because the same thing happens for other ones.
Yeah. So there's some nice efficiencies there.
Correct.
once you learn it and know how it works. Yeah, very good. So yeah, well, I forget how far we were into what computer programming is and how does it work, but is there more you wanted to say on that? We were just basically talking about variables, I think, actually. So if you want to continue on from there. Oh, I was going to ask you, do you use while loops?
No, well, I mean, they exist.
Okay.
But I avoid them.
Okay, why is that?
For the most part. Usually, they have their place. Usually a for loop so a while loop, you just have to make sure that you can get out of it. So that is a case in point where a while loop, you can strand your CPU gets maxed out and you never get out of your loop.
Okay,
you're stuck in your loop forever.
Tell me, what is a while loop so that...
So it's exactly what it sounds like. While, and then you have a condition. While a condition is true, your loop is happening. So if your condition never goes false, then you're stuck in your loop forever.
So couldn't you put that to a physical control that an operator could turn off?
Right. So in a while loop, so backing up to how our code runs. So in a PLC, it's different than what you'd be doing, I think, in Python, whereas it's not event based, it's scan based.
Okay.
So all the inputs and outputs. So one scan happens in 10 milliseconds. So
what do you mean by a scan?
So it starts at inputs. All of the inputs get read in.
Okay.
At the beginning of one scan.
Okay.
And then it goes through your code execution, and that we have set up. So certain things happen in certain orders. And within that, it'll jump into one program, run through all that code, and every if statement you have in there gets evaluated. So if it's true, more code will happen. If it's false, it won't happen. It jumps over to the next thing.
Right.
And then it gets done one program and jumps into the next program, whatever. So all your code gets executed.
Okay.
And then at the end, it writes the outputs. So within your code, you might set outputs, and then they get written to the outputs. And then the next scan starts over.
So you'd call a scan, is that terminology used for running through a code one time?
No. Not? So a scan is, if it's scan based, which PLC code is, then the same code is getting executed whatever your scan time is at. So we set our base time, a scan time, to 10 milliseconds.
Okay.
So that means every piece of code is getting scanned 10 milliseconds.
Okay.
So that's different than the other type of programming is event-based. And that is a lot more common just about everywhere else. So that something only happens, code only gets executed based on an event, like a button click.
Right, yeah.
Or whatever on your computer. So the reason to do scan-based for PLC is because you have, there's certain code that you want scanned all the time. So this is happening 100 times a second that your code is getting executed. So back to the while loop. If you have a while loop that is too long, then you run beyond your 10 milliseconds of scan time. And so it starts messing things up. It becomes dangerous. And if it's infinite, then you're no longer reading and writing outputs, and bad things happen.
It'll crash the computer.
Or you're just stuck not doing anything, not accomplishing anything with your code. So
thank you. So that was still back on, we were kind of talking about variables and got into if statements and then for loops. Then I asked you about while loops. So was there more you wanted to say about computer programming and how it works?
Sure. um, so again, this is back to PLC code. So I don't know if you've heard of memory leaks.
Nope.
Okay. So code can sometimes have a memory leak, and that's where it uses up memory of your computer and never lets go of it.
Okay.
So back to our PLC code, it actually can't have a memory leak because everything is defined beforehand. So when you have when you're writing your variable, you can't use a variable unless it's defined. And when it's defined as a data type. So a Boolean, for example. So that has a fixed size in memory.
Okay.
And it never changes. So our entire code set is a fixed size. It doesn't take up any more or less memory.
Okay.
It doesn't matter what's in it. So if my Boolean's true or false, or if I have a string that has like a lot of text in it or no text in it at any given time, the amount it takes up in memory is the same.
Okay.
So it's a fixed size in memory. So that becomes this is just going into a little bit of our code size now, and something that I find interesting. Back to the scan-based thing.
Okay.
So our fully compiled code size is 79 megabytes. So that doesn't sound like very much. That's the size of data. And that runs, it gets scanned once every 10 milliseconds.
Okay.
So all that code gets executed every 10 milliseconds. And so it runs on a computer, and it's running an Intel Core i7 is the CPU, so a high-end CPU. And this all has to happen on a single core in that CPU. So certain computers, they say that like you have different cores, and it's great for running multiple processes at once, but for this it can't. So a scan time takes it takes up 75%. So just to execute that 75 megabytes of code keeps that single core running at 75% CPU usage on that core. So it's how interested are you in this?
No, it's great. Yeah, keep going.
So then we have the scan time of 10 milliseconds, so 100 times a second. But there's certain things that have to happen faster than that because it's not quick enough to read in certain things. So like a flow meter, we were talking about applying liquids.
Yep.
Some flow meters are, they send a pulse every whatever. I don't remember what it is, every 100 grams or whatever.
Okay.
That goes through it, it sends a pulse. And that's how you know how much has gone through it.
Sorry, this is a pulse of...
Just like electricity.
Okay,
like
just kind of a signal? Or
Yeah, exactly. So so that things like that we have on a high-speed task. So those inputs are getting scanned 4,000 times a second. So that scan time is 250 microseconds.
Okay.
So this all still happens on the same core. So this means that when your scan starts, it reads all the inputs in from our project. And then it starts executing your code. So it starts going through like your program and it gets through. But now every 250 microseconds, it has to interrupt where it's at executing the code and read in the high-speed task variables. So the flow meters, it has to check them.
Okay. Yeah.
So that happens. It interrupts it where it's at. That happens. And then it jumps back to where it was and keeps executing.
Okay.
And then again, 250 microseconds later, that happens again. So when you're running at 75% CPU usage, it means that in that time, in one single scan, that code gets interrupted 30 times to check for high-speed tasks. So it's amazing.
Yeah.
what happens at a computer level like that. So
wow.
So you can also do, while we're talking about timing of things, you can synchronize your outputs. So your outputs all get set at every 10 milliseconds, like I was saying. That's our scan time. So you can change your scan time. So if you need it to be faster, like I was saying, the 250 microseconds.
Yeah.
But then sometimes for some applications, and this goes way beyond what we do, but I think some scientific research where it becomes really, really critical that outputs come on at the same time. They have something called time synchronization.
Okay.
So this is when it goes out to your output card. It actually remembers the path, how long it takes to get there and how long it takes to get to the next card. So you might have like an Ethernet cable, just like you plug into the internet, something like that, that's connecting one card to another card 100 feet away or whatever, or all around the plant you might have output cards. And you can set up time synchronization so that these outputs come on within 10 nanoseconds of each other.
Okay.
Or it's measured in 10 nanoseconds.
So
that
like
means
0.00, like to the 8th decimal place, there's a 1.
Right.
Yeah.
Yeah. So, So then in 1 nanosecond, light travels about a foot.
Okay.
So in 10 nanoseconds, light travels about 10 feet.
Okay.
And in 1 second, light travels about 300,000 kilometers. So that gives you an idea how fast 10 nanoseconds is.
So wait, say that again.
So, so this, you can turn on outputs at about 10 within 10 nanoseconds of each other.
Okay.
So this is just to get an idea how fast 10 nanoseconds is.
Yeah. Okay. No. Yeah.
Light travels about 10 feet.
So we're breaking up a second into a billion parts.
It would be to the -9. Yeah.
So it'd be a billion.
Yeah.
Yep.
So 10 nanoseconds, light travels 10 feet.
Okay.
Now to compare 10 nanoseconds to a second, light travels 300,000 kilometers in 1 second. Yeah. Wow. So that it's mind-boggling how fast you can get with setting outputs and time synchronization and things like that.
So are these things traveling at the speed of light? I mean, are these signals traveling at the speed of light?
No. So your signals are that's what time synchronization is.
Oh, it puts
so
it in at
weights
that.
it.
Yeah.
So it's like, okay, it takes it this long to go through the wire to here. And so it waits that long and then turns them on.
Okay. Yeah. So you can control it that well.
Correct.
Wow. Yeah. So, yeah, was there more that you wanted to say on the computer programming and how that works before you get a little more into what you do?
No, we can move on.
Yeah. So maybe you talked about this already, but talk a little bit more about the type of programming that you do or the things that are involved in that. Maybe the languages, you talked a little bit about that too, but yeah, just a little more on some of the specific programming that you do, since there are many types as we've been talking about.
Yeah. So we talked a bit about structured text, which is our PLC program.
Okay. Yeah.
In the HMI, we would use Vbscript, at least currently that's what we're using.
Okay.
It's a different application. So some of that's drag and drop. So you have a button image. So again, this is building the user interface. You would just drag a button onto the screen.
So there's already a kind of a button drawn that
exactly
looks, does it actually look like what it's doing or not?
Yeah. So like when you're creating the HMI, then you have a screen, and so this is all done by right now we use Indusoft mostly, and we're starting to go into back off what we use for PLCs. They've come out with their own HMI application so that you build it with. So that's based more on web development languages. But Indusoft is you drag a button onto the screen, and it looks like it'll look to the user.
Yeah. Okay.
So, but then when you double click on the button or whatever, you can set what happens when it clicks.
Okay.
So then that's where Vbscript comes in Indusoft.
Okay.
So that would be another language where every time somebody clicks on a button, what actually happens is written in Vbscript.
Okay. So is that text-based code then?
So it would look similar to any other language, basically. Okay. You still have your keywords, and it's still, you create your variables, and there's different pre-made libraries that different languages have. So Vbscript would have a certain library for talking to the database.
Okay.
Or whatever. So that's code that just resides on Windows, basically.
Okay.
That is written by somebody else.
Yeah.
And it's
kind
written by Microsoft developers or something that I have no idea what that code actually looks like.
Right.
inside.
But you know that when you use one of those
Correct.
terms, then you know what it's going to do.
Yep.
So can you give me an example of something you would use regularly that's kind of a pre-programmed term like that?
Yeah. So if database interaction is a main one, but just like at a much simpler level, now becomes like a keyword where it gets the date and time.
Oh, okay.
So you just say now, and that's somewhere it's getting the code to get the current date and time.
Okay. Very good. Yeah, just what you were talking about with the like being able to pull a button onto the screen and
Yep.
set it up like that. I'm doing a programming lab right now too. It's called Lab View, and everything is kind of more of a visual programming. And what you do is you bring in those different things that you can set up a for loop, and you can have your booleans and your variables and operations and things like that. But then what you actually do is you wire the different things together in the order that you want them to work.
Yep.
And it's a lot of the same things as text based. Like I was saying, you have your if statements, and but it kind of gives it that visual look. I guess that's the idea with it. I haven't done much with it, but it kind of reminded me of what you were saying with dragging things on and doing more of a visual part of it. Did you say what you wanted to about, you were talking a little bit about databases and how they work. Did you talk about what you wanted to there? Or is there more that you wanted to say on those?
When I started at KMR, I didn't really know what a database was. You hear the term and you don't really know.
Doesn't it just store things? Or?
Yeah. So think about it again like an Excel sheet where you have your columns that are predefined, and then it just stores data. But then instead of like an Excel sheet, you interact with it through code. So T-SQL is the code language of interacting with a SQL database. That's what we use. Yeah, that's exactly what it is. I mean, so then on a button, I might actually have an insert into the database. So I can actually record whatever information that they're setting up. So I have, you can make it a user interface to the database. So
is it set up to pull things from a database and use them in executing the machinery, or is it recording everything that's done into a database? Okay.
So we record everything that gets done to the database, but we also store things like parameters in there.
Okay.
So certain things have different, so for purging a conveyor, say, you need to set up a parameter for how long it needs to run until you consider it empty of all product. So that type of thing we would store in the database. And on the HMI, there would be a user interface where they can change that. So then when they save it, we would save it to the database. And then in our PLC code, we would read that back in. And then that's how long we would run the conveyor for.
Okay. So that's all set up to work together. That one change will make it work
on the whole
with
system.
So that all has to be. Do you have to?
So we have to write
together.
Yeah, we have to write code. Well, you have to set up the database to have that table.
Okay.
You have to write code in the HMI so that the operator can view what's there and also change it. And then you have to write code in the PLC to read it in and to actually use it.
Okay.
Yeah.
Yeah. Very good. So you can. Yeah. Sorry. Go ahead.
Well. Okay. The other thing about databases is they're relational, or that's what it's meant to be. So if you take a simple example of a product at a store, so there you might have a product ID, which is just a number. It means nothing. But then with it, in the same row, you have a description, which tells you what the product is. And then you might have a price, what you sell it for.
Yep.
So there's a lot of other things that you want to keep stored about that product. You want to know who the suppliers are. You might want to know what category it belongs in. Is it in, so the website, is it in tools, or is it in home improvement or whatever, right?
Yeah.
Like that type of thing. So then instead of storing that all in the same table with it, you use that ID that's with the category in another table, and then that way it becomes dynamic, I guess. You can just keep adding rows. So instead of having an extra column for supplier 1 and supplier 2 and supplier 3 for it, because you don't know how many suppliers might supply the same thing.
Right.
You make a new table which has the product ID and the supplier. And so then the same product ID, you can just add another row and it becomes dynamic how many suppliers you have.
Okay.
So that I think is the fun of working with databases. It's relational. The idea is that you don't store the same information twice, kind of.
Okay.
Like you want to keep it so that it's in one place, and that it's dynamic, so that down the road, if you add another supplier, it becomes a database entry instead of actually having to change your architecture and add another column.
Oh, okay. So it's easier to work with because of that. And it's a simpler process to input data. I mean, to get that data in.
Yeah, and it become on the back end becomes a lot easier.
Okay.
So
yeah.
That's I find that the fun of working with databases.
Okay.
Is how they relate to each other.
Very good. Yeah. You can, as you have more things that you think of that you want to kind of add to what you've been saying, that's great. But maybe you can talk a little bit about what the process is of planning and implementing a program as you, I don't know how much you can say about that, but as you've been talking about it seems incredibly complex to me, all the things that have to come together for a mill system to work. So walk me through kind of what you as a team do in order to get it from a beginning to final implementation.
Sure. So you don't start from scratch every time. So you start from a code base that you've already made.
Okay, that was actually a question I wrote down is, can you reuse these things from project to project?
Yeah, it would be an incredible amount of work if you had to start from scratch every time. So obviously then you might start from a previous project, or we kind of have like a standard project that we keep, that anytime you develop something new, you put it into that project. So that way that's what we start from for a new project. So then at that point it becomes a lot of stripping down things and changing and stuff, because you don't use all of that for a mill. So again, how I was talking at the beginning, how you kind of have different processes. You have receiving and you have batching, that's like where you mix things, and you have pelleting, and then you have loadout where it goes. So that's kind of how we break it down into different developers too. So somebody I might work on receiving or whatever, and then it becomes starting from that code base, and it becomes big using that flow plan that I talked about that the design side would have, because you have to know what conveyors feed into what other conveyors and to what bins they go to and that type of thing. So that's kind of where you start with, and that's kind of how we break it apart to begin. So that's the PLC side, and the HMI side is the same way. Is you have different, like a whole bunch of different screens. So for our project, I don't remember how many it is, but over 100 different screens. But some of them relate to receiving. So if I'm working on receiving, then I'll go to those screens and I will actually make it so that the number of bins that actually exist are what's shown on the screen. And
so this is maybe a simple question, but do you start with some of those simple, clear things and just try to put in those things that like, this needs to happen first?
So on the HMI side, that's absolutely often what I do. Very simple is you get the objects on the screen that you actually know exist there. And then that's kind of where you start before you start changing any of the code behind it.
Does you've talked about several different parts of the entire project. Is there something specific that you've kind of has become your thing, or do you as a team, do you work on you all work on different parts of it?
Right now there is 4 of us, and we all kind of work on everything.
Okay.
I had mentioned that we're going to we might start using a different HMI platform, the Beckoff one, which is more web-based.
Okay.
And so that there I have done a bunch with. So that's kind of what I'm working on right now is a project coming up next summer that will use some of that. So
okay.
That's
very good. You maybe have talked about this a little bit, but have you had to learn how to read feed mill plans and understand what's happening to be able to know how the program needs to be run and things like that?
Yep. So that is the nice thing about the design side being right there.
Oh yeah.
They have.
You can ask them what they mean by this.
We have access to all the drawings, and if I don't understand something that's happening in a drawing or whatever, I can just ask them.
Okay.
Yeah.
Have you ever had like massive miscommunication where you programmed something that was completely different than what they had in mind?
No, I don't think so.
There's enough communication there that can be caught.
At least not massive. Sometimes things get miscommunicated about how something should be programmed, but not usually nothing that doesn't take that long to fix.
Okay. Yeah. So you said that you work on these projects for months.
Yeah.
So you're just working using the plans, trying to get all the programming correct as for the system to work. Is that kind of what most of the work is?
Yeah. So then a big part of it as you're developing, and then for sure more so at the end is testing it.
Oh yeah. So that's where I was going with that, is how you do that.
So we make a simulation basically. So this is again just with our code. We simulate the inputs and outputs and stuff. So that way it's basically like you're playing a computer game.
Oh, neat. Yeah.
So when you start a conveyor, it looks like it's running on the screen because we simulate it. So that becomes really important. I don't know. It would be really hard to develop something that works without being able to try it out like that. So
would it have been done in the early days of computer programming where you wouldn't have known until you started implementing it? Like that takes software of some kind to be able to see the different parts working or not?
Really the part that you don't have is the physical, so inputs and outputs.
Okay. But you can't test that until it's on?
Not really. Like we often test so that we for sure get our links right. So like you actually link a variable to an output.
Oh, okay.
So we test that once we have all the I/O set up before it goes to site. But as far as simulating it, it's just code, so that link gets written to a variable.
Okay.
So for simulating it, you can just simulate writing to that same variable with something else. So that way when you hit start, it simulates writing the input to say it's running.
Okay.
Or whatever.
Yeah.
So it looks basically like it does when it's actually live.
Oh, very nice. So so you're doing that. You're probably doing that testing all along. Like you write a small part of the code and see if that works, and then.
Yeah. So for the first day or whatever, when you're starting on, you probably don't. First couple days maybe you don't simulate anything because it won't work.
Oh, okay.
But then it happens all the way through the process of developing. Yep.
So eventually you talked about you go on site sometimes.
Yep.
Is that to do once the equipment's in place?
Yep. So that is on startups. So if it's a new mill, last winter we did Jones in Linwood, the new mill there. So I was on site pretty much every day it was at least 6 weeks.
Oh, really?
Yeah.
So it is a long process.
Yeah. So not everybody from our automation team would have been.
Okay.
Part of that was after they were already running, but it's just working out bugs. And with that too, it's when it's new equipment, then often there's mechanical issues and stuff. So it's just kind of to make a smooth start, as smooth as can be. So, but there, for the testing of that, we're involved with actual testing of everything. So every limit switch out in the mill, we go find and trigger it and watch to make sure that on our HMI we see that limit.
Okay.
So that's where you catch anything where if it was linked to a wrong limit or something, then that's when you have to catch it. So
it's
a critical part.
Yeah.
Yep.
So do you have a systematic process, protocol of going through to make sure that you catch that you've tested everything?
Yep. So we have another part of our job is drawings for RIO.
Okay.
To say that way they know which conveyor goes to which input or output point. So we use those drawings and a highlighter, and you make sure that every single line gets highlighted.
That you've tested it, it works. That you tested the one that you're planning to, or that you're trying to test.
So then there's usually two people or whatever working on together.
Okay.
One person at the HMI watching and stuff, and one person out at the limit switch triggering it or whatever. Yep.
Well, so in that, are you troubleshooting? Are you debugging?
Hopefully not.
So that's all. You hoping that program's all been good to go beforehand?
Yeah. So we do like a lot of your simulating back at the office catches a lot of things.
Okay. Yeah.
But there's always often at a new mill you'll definitely find things that have to change a little bit.
Okay.
So there's.
So what are some of the bugs that you'll run into in programs? Like what's some of the things that problems that you have with code?
Sometimes they're the weirdest things that don't show up for like years.
Really?
Yeah.
Like,
so
how does that happen?
It could be a weird thing. Like, so a lot of things rely on timing. So you might have a statement that this executes, but it has to execute before this or whatever. And certain things that have to come back on a power cycle, it has to return to the same spot it was.
Okay.
So there's certain variables that we keep in memory that on a power shutdown or whatever, they get written to the hard drive before a shutdown.
Okay.
So there's a tiny little UPS or whatever that makes sure that happens. So sometimes something like that, if it's if for whatever reason power goes out, it could be in some spot where it's never caused an issue before. But now when it comes back on, it should have been in a certain state and it wasn't.
Okay.
Something like that would be an example of.
Is that something you've seen, or did you just come up with that?
I'm not sure if I've seen that exact thing with a power outage. There's other things that are sometimes wrong, but they don't matter enough that you don't catch on for a long time. So sometimes there's things like that where it's just a little thing where we might be trying to record something and we're recording it of whatever. I don't know. It's hard to think of a perfect example, but
it might not even get caught. Like there might be a bug that's there.
That's possible.
Yeah.
Yeah. But not obviously those are tiny. Like everything that matters is
It won't get very far if it's a major issue. Yeah.
Yep.
So and you just kind of learn as you go along what to look for in running those simulations and those tests, what's needed in order for it to be working, and then kind of learn what to look for to fix those problems.
Yep. It is definitely something you just get better at as you do it.
So basically. Would it have been something that you would ask for help if you're having trouble with something, or what's kind of your process in figuring something out?
That definitely happens sometimes if you can't figure it out for too long, get someone else's opinion or whatever. But depending what it is, sometimes that helps just as much because you start talking about it out loud. Or whatever. Like sometimes they become, if you've looked into it for a while, then it's hard to bring somebody else up to speed away on something. But
that's true.
My foreman, I guess, our project lead on the automation side, would have written a lot of this code originally that sometimes, so he has a really good understanding of.
Is it in the languages that you use, is it typical to put comments and things in with it?
Yeah, so that definitely Comments are very helpful. Sometimes they can be overdone because your variable naming should tell you what's going on too.
Okay.
So the name of your variable should be something that is meaningful.
Yeah.
Or whatever. But yeah, absolutely. Comments.
That's something I hadn't thought about until that was one of the things that the textbook said almost right away is to put in lots of comments because code is really hard to read.
It is.
Even stuff you've written.
Yep.
And you come back to it a week later and it's like, I have no idea what I was trying to do there.
There's definitely times when it's easier to write code than to read it.
Yeah.
It's because you understand what you're doing. But coming back to read it, you have to try to re-understand what you did.
Yeah. Do you are you ever able to Google things to troubleshoot problems? So is there enough other developers using the programs and things that you use that there's kind of a library of source resources out there? Or?
So in the PLC side, not as much.
Okay.
But for sure the other languages that are popular, and especially with what I've been working on recently with the new HMI that uses web development languages, there's all kinds of help out there.
Okay.
Stack Overflow is a lifesaver.
Okay.
It's just you can post a question and people answer. I've never posted a question. You can almost always find the question that you want to ask. Somebody else has asked.
And it's just people being helpful, or?
I'm not actually sure how it works.
Okay.
I think there's definitely a system behind it where like people get rated on the good answers they give. Okay. So I'm not sure if there's any money involved, or I think it would for sure look good on a resume if you had.
Oh yeah, if you had a good rating on there.
I don't know though.
Yeah, fascinating. Yeah, I don't know if you had more to say on the troubleshooting and debugging process, but what are some of the elements of a good program? Are there things that you can look at to know that it's a good program, or is it just if it works or not?
So it's not just if it works or not. There's hundreds of different ways that you can program the same thing if it's complex. And working right now, we're at a team of 4, and it's nice if you all kind of keep the same way of programming.
Okay.
Because then it becomes easier to read and to whatever. So for me, that was pretty easy because I learned from exactly from what I was reading, right?
Yeah.
The only code that I really learned from was if somebody were to come from a different background, then they would probably have a different style of writing code. But for the most part, we're all very similar. Okay. So that's really nice. But again, it's not as far as elements of a good programming. What's good about it is that we're the same.
Okay.
But the other thing is, so like your while loop example, if you can, I would absolutely use a for loop, something like that. You just avoid a while loop will work, and you can make it that it will always execute and get out. Like you can make sure there's certain ways to make sure that it will always jump out of the loop. But a for loop does that for you. Yeah. Right. So when it gets to the end, it'll go out. So there's certain things like that where programming, there's other, again, going back to just style, you can have, so say you have a Boolean, so just a true or false, and you have another Boolean, and you want to say if this is true, then this one becomes true. Yeah. So you could write that if this is true, then this one becomes true, and end it. But another way to write that is just this one will become the other one. Oh, okay. If you follow what I'm saying. So it becomes simpler to read and less code to write. Yeah. You're down to 1 line instead of 3.
Is that just simpler to read, or is there advantages to the computer running it as well with that?
If there's any advantages, it's hardly at all.
Okay.
So, see, I don't know. We've done a little bit of testing, like on timing of things. Yeah, things like that. But, I mean, it's so minuscule.
Okay. Well, I was going to ask you about this. I don't know if you can answer it or not. And I don't know enough to know if it's related to what you were talking about with your, the amount of data that the one core processor, whatever it was, runs. But something that you run into occasionally in physics calculations in programming is you get a more accurate answer sometimes in taking an integral or something in calculus by running through a loop more times, like making just the more you can split an interval up into the smaller pieces, more pieces, so smaller pieces, the more accurate your answer is going to be. But you have to sometimes, you'll do so many times running through a loop, like if you'd run through it 10 billion times, it actually will take longer for the computer to run that. Is that something that you guys are thinking about in developing your programs?
Yeah, so code efficiency is definitely a big thing, especially because we're running so close to, we're at 75% on our largest project.
So that does all contribute to
so code efficiency is definitely something you think about, and we try to keep down. So the example of what you're saying about a loop, so what I was saying about how we do conveyors in a loop, so that you just make the array size bigger. If you just increase that array size a bunch and it's conveyors you don't actually have, then you're executing a whole bunch of code that will never ever do anything.
So the code's still running even though it's not connected to a physical.
Correct. So that's a very simple code efficiency that you try to avoid. You don't use array position 1 and array position 8. You use 1 and 2 and then that's where you end the array.
Right.
So
so you don't want to have just, I don't know if empty code is the right word, but things that aren't doing anything in it. Okay.
Yeah, and that's a very simple example, but there's other things like that where you can have code that gets executed but doesn't do anything.
Yeah. And so you said that there's hundreds of ways to do things. I don't know if there's that many, but there's often multiple ways to do a process. And there's probably one's going to be more efficient than the other.
Sometimes. But not always.
Okay. Yeah. So I was wondering if you're trying to always think about, how can I make our general code more efficient, or is that not really something you spend time focused on?
More than efficiency, I think about how to make it dynamic. So if something changes a little bit, then that I don't need to rework everything. Like the whole example of a conveyor, adding another one. You take that same concept into a whole bunch of different areas. So if the physical things change, if they want to add another one like this, or if they whatever, then how can I write my code now that it becomes very little work to change it in the future?
Okay. Yeah. So. This is a very, very simple question, but has your typing gotten faster since you started coding?
I don't know.
Were you already a fast typer before you started or not?
Yeah, I don't know what you call fast. I think I could do 50 words a minute.
Okay.
I don't know. But see, I don't know if I have gotten a lot faster because IntelliSense. So I don't know if you have that, if you've experienced that at all, but it's like you start typing a variable and it auto-completes for you if you hit tab. Okay. So that is a huge thing.
Oh, nice.
Yeah, absolutely. Use all the time. So you start typing, then you hit tab and copy and paste some things and whatever. So it's pretty rare that it's not like I'm just like looking at a Word document and typing, trying to get speed. It's always, from the top of your head, kind of like what you're thinking.
Yeah. And so. Oh, great. Do you have you gotten any equipment or like any hardware to make your coding better, or do you just use a regular computer?
Like what our PLC code runs on, you mean? Or
no, I was just meaning for your own personal.
No, so like at home.
Yeah.
No, but most of what I do is through a VPN to work.
Okay.
So actually, my work computer is still doing most of the.
Okay. No, I meant do you have like a special keyboard?
Oh, that away. Yeah. No, I don't. I don't even have special mice. Really, I have a normal mouse. I have linked like the additional buttons to like page up and page down.
Oh.
So that going through code, it totally becomes what you get used to though.
It does, yeah. And yeah, I just thinking about if it would be possible to probably get into all kinds of
Yeah.
setup things and what you.
Multiple monitors is a must.
Yeah.
Yeah.
Yeah. No, I've with classes being online.
Mm-hmm.
I finally brought out my monitor that I hadn't been using for a couple of years
Yeah.
because you need to to read a textbook or something on or have a class going and then have your regular computer. I find that finally forced me to have more than one monitor. It's really nice. Yeah. Anything else that you were going to talk about or wanted to say on programming side before we get to some of my miscellaneous questions here?
No, I don't think so.
All right. I don't know if everyone's interested in this, but it seems like in the last couple of years maybe in the general culture society, there's been this talk about AI and artificial intelligence, and I'm somewhat interested in this, and I think we've talked about it occasionally at the past, and I don't know if you can. I think you told me you don't consider yourself an expert at all, and I don't either, so it's probably not worth listening to us much on this, but I thought it'd be, I just enjoy talking, hearing, discussing different ideas on it. So I thought I'd throw a few questions out to you and see what you think, or from what your experience, what you've observed. So please, no one take too much from this, or go research it, look it up yourself. But I thought it'd be fun to talk about it for a few minutes. So you do programming. Have you gotten into artificial intelligence at all in your work, or is that not, do those two domains not intersect at all?
Not really.
Okay.
So I think it depends what you call artificial intelligence. So one way I can think of that we use is so when you're batching like into a scale, then obviously you can't just stop it when you get to your target, because some will still fall.
Okay.
And the bigger the auger, the more will fall, or the heavier the product, the more weight you'll be off by, right?
Right.
Depending what product it is. So different things like that. So you have to try to predict when you're going to stop, so that your free fall amount hits your target. So there we do we have a learning thing. So it learns from previous times or whatever.
Okay.
So that it'll predict, it'll get smarter and smarter. So when you first start up a mill, usually your tolerance, like you're way out on some of your weights, and it starts getting better and better. So that type of thing is maybe, it might kind of fall under the category of like narrow AI.
I think it does, because it's a dynamic program kind of.
Yeah, like you learn it'd fall under, I don't know, I guess you're learning from past results. So, yeah.
But is it written in that to take these weights and then that, depending on what the weight is that going to change when it stops it? Like, is that all written in to respond to how much it's overweight, or?
So it only learns based on previous experience.
Right.
So if it's if you were to change products in the bin to a lighter product or something, then it would have to relearn again.
But a human's not looking at that data and then resetting the parameters themselves. But something needs to be pre-programmed ahead of time to respond to those.
You have to look, you have to do a check basically on past results and make a change.
Okay.
Yeah. So that's all done by
ahead
code.
of time, that it responds on its own.
Yeah.
So I guess that's kind of an element that's used. Is that what your understanding of artificial intelligence is, or is it more than that? You said it's a fairly narrow part of it.
Yeah.
Maybe.
So I think like general AI, like if you're just talking to people like me who know very little about AI and you just say AI, you start thinking about like intelligent like a human.
Right.
And I don't think anything like that exists yet. Well, it doesn't. Nothing quite to that extent. But things go far beyond what we do in like the same way, but just way larger data sets and coming up with way more complex things. So I think one type of AI would be supervised learning. So that would be like there's a picture of a dog, and then there'll be a person that says dog for that picture. And then AI will take that picture and find the dog on it, and then find similar pictures like that. And so then it's learned what a dog looks like or whatever. So the more different styles of dogs that somebody's entered dog in for, the smarter it becomes.
Right.
So that type of thing would be like a supervised, an unsupervised way, like where it just learns on its own, I think would be trying to look for, you might have things that look like categorized data. So like your Google News feed, when you're scrolling through, similar headlines are grouped together, or things about similar events or whatever, right? So I think that's probably done with AI. It's just looking through articles and combining them based on.
Yeah. So I asked this to you just from your experience and how you have a better understanding of how computers work or how programs can be written for computers than I do. Do you think that artificial intelligence as it is now is more than just sophisticated programming and really good programming, or is it moved into a different category?
So I don't feel like I know enough to answer that.
That's fine.
It goes way beyond what I know about programming.
Right, yeah.
So there's things called neural networks. So one thing about PLC programming is it's very defined, like the same things happen every time.
Right, yeah.
Whereas AI programming starts to different things happen it starts assigning value to different things.
Oh, okay.
So when I get an input in the PLC programming, I treat it for what it is.
Yeah.
But different AI, I think, starts assigning value to inputs and then doing different things based on what value it was assigned.
Oh, yeah.
So, yeah, I don't know. It goes beyond what I know.
Yeah.
It goes beyond programming I do.
Right.
But I don't think it's anywhere like the general AI where you just have.
Where it, and then you start getting into the question of what is intelligence and how do you quantify it, and it can make it kind of hard to talk about. So you mentioned a few ways. Have you seen advantages to AI? I mean, you talked about the way that a system can kind of learn within yours, and I think there's real benefit if the computer can be doing the learning and get better at making some judgment calls, I guess. Have you seen instances of that?
I can't think of anything really offhand. At some point, again, it's kind of hard to know what's just programming and what's AI. Have you ever driven a car with adaptive cruise control?
No, I've nothing very smart.
Yeah, I don't have anything very smart. I have driven something.
Okay.
That was a little bit like that. I don't know how. But yeah, so that, or where it kind of like jiggles the steering wheel if you go over a line or something like that. So I've driven something like that, but I don't own anything like that.
Yeah.
So I don't know. Again, that would probably use at least the more complex ones would use AI for vision recognition.
Okay. Yeah, fascinating. Yeah, I don't know if you have any more to say on that. And I put down the question here of, do you have interesting facts or stories to share? And you shared a few facts there, so I don't know if you'd covered all the ones that you wanted to, but is there anything you wanted to, stories you wanted to share or things that you found interesting that you want to talk about yet before we end it?
No, I don't think really. I'll say this about starting. Well, one thing about our job that I really like is the variety. So a lot of programmers, I think, if you program in Python, then that's what you program. So we get into, I've programmed in, structured text is the PLC, Vbscript is our one, HMI, T-SQL is database, and then now starting into the other HMI would be like things in C# and the web languages, so JavaScript or TypeScript and HTML and CSS. So I love that variety, and I think that's pretty rare that a programmer gets to use that kind of that exposure.
That is neat. Wow.
one other thing I'll say, just about, as I think about talking through this, when I started at CAMR, I didn't know about anything that we talked about here. And there were times at work where I almost fell asleep. I was getting like more sleep than I normally do. Like I think at least 8 hours a night.
Okay.
And it was just brain overload.
Wow.
Where it was, I'd be at work and I'd be almost drifting off and be like, come on, that's not who I am. But so it was a big learning curve for me. But I really enjoy it. So
that's great. Well, it does wear us out to learn new things.
Absolutely.
I read somewhere, I think it was when I was reading a book on teaching, and it was reminding us reminding teachers how much their students are being worn down with the new information that they're getting throughout a day. And it gave the example of when you're on a trip, you can sometimes be getting as much sleep or more sleep than you normally do, but you'll be really tired. And that's just your brain taking in all the new sights and new cultures and just so many things out of the routine that you're not used to. And so that it really wears you out. So that's fascinating that you noticed it.
Yeah.
You got sleepier on the job than you are now, or?
Yeah, absolutely, than I am now. And
there
was another guy that started same time as me, and I could tell with him too, like the first couple months it was an overload.
Yeah. I didn't put this question on, so if you can't think of anything, that's fine. But do you have any advice for someone that's trying to learn how to code, learn how to write programs, to just starting out with it, since you've had that experience?
Yeah. I think there's a ton of online things about coding.
Yeah.
And I mentioned it before, but W3 Schools is a free one, which gives you a good overview and actually goes pretty in depth in some of the programming languages.
And that's free? Is that the one that you said is free?
That one's free. So that would be a good place to start. Another good thing to think about is what you want to do as a programmer, and then look into what languages are common in that application or whatever. With that, once you learn one, it is definitely the second and third and stuff come easier.
So some of those concepts will carry through any programming language.
The more complicated of one that you learn, the farther it'll take you in the next one you try to learn, I suppose, or whatever. So some of the ones that we didn't get into, I talked about how ours runs on one core. So in C# you can start multi-threading things, and so then you have to start making things thread safe, that it actually something runs here and you don't mess that up by running it on a different core or whatever like that. So I don't know very much about that, but it's something to think about. Think about what you want to do as a programmer before you just start looking into different languages.
All right. Well, that's great. And thanks for teaching me so much and putting up with my many questions. And
it's been fun.
Good. Yeah. I'm glad you were able to come and share what you do. So thank you. Thank you, everyone, for listening. And thank you, Jamie, for sharing your knowledge with us. I love learning new things about systems and how they work. And so I was quite fascinated to learn a little bit about feed mill systems and about the computer programs that run them. So thank you, Jamie, for sharing those things with us. I also was fascinated by the fact that Jamie learned computer programming on the job and didn't go to school specifically for computer science or computer programming to learn the things that he knows to be able to do his job. What that tells me is, especially with some of the websites that he talked about, which I've included on the everydayexpertise.ca website. If you go to this episode, you can find links to those websites there. It is possible to learn computer programming on your own. If you have a desire to just learn something new for interest's sake, or you'd like to expand your skills to maybe find a new career or something like that, you definitely can pick up and learn computer programming on your own. And there's plenty of resources out there available to help you with that. So if you want to learn more about programming, go ahead and go explore it on your own. If you'd like to connect with me, you can send me an email at contact@everydayexpertise.ca. I'd love to hear what you think of the podcast up to this point, and to hear if you have suggestions about topics that you'd like to hear me talk about to someone about, or if you have a suggestion for someone that you'd like to have on. Thank you to those of you that have given suggestions so far, and I'd love to hear more from more of you if you'd like to share. That's all for now. Join me again next week to learn from the expertise of everyday people.